Now, when you try to find units for Kc, it's like physics, homogeneous equations in physics. Concentration, the unit for concentration is mole per dm cube. So the numerator is mole per dm cube squared divided by mole per dm cube. N2 is mole per dm cube, and then you have H2, which is mole per dm cube, and that's cubed. So this is you have to simplify the unit now. ठीक है, probably you must have done similar things in physics.
Yes, I understood it.
अच्छा, लेकिन the easier way is कि instead of mole per dm cube use x. ठीक है, because I mean you can make a lot of mistakes. So it's x squared divided by x into x cube. You simplify this. It's easier to simplify. X becomes -2. And what was x? X was mole per dm cube. So put mole per dm cube in the expression to the power -2, and you can then simplify. Okay, so always remember, I'll do one more. Uh, for example, this one, the Kc for SO3. I'm going to try and find the unit. It's going to be x. X is mole per dm cube. So x squared divided by x squared into x. So it becomes, if you simplify this, it becomes x minus 1. So it's basically mole per dm cube. It's basically mole per dm cube minus 1. So mole per dm cube, and the power is -1. And if you further simplify this, this becomes mole -1 and dm3. ठीक है, is this clear? Barida, is this clear? बाज गया?
Yes.
Vinay?
Yes.
चलो ठीक. So, so Jeeta, is this clear? Yes or no? I said now we're going to move towards. Now we've learned how to actually write Kc, and we figured out that's the first thing, you have to get that right. Okay, that's the most basic thing. And after that, this is where the problem becomes tricky. Okay, so the first thing is, as a first thing, when solving for Kc, I mean, remember this point. Now, Kc is only applicable if the reaction is at equilibrium. Because if the reaction is not at equilibrium, if the rate of forward reaction and the rate of backward reaction are not equal, that means the concentration of the products and the concentration of the reactants is changing. But if the forward reaction is faster compared to the backward, then obviously the product's concentration is not constant. It's constantly increasing. So when solving for Kc, remember that the equilibrium has to be attained. It has to be present. That's the first thing. So if a reaction is not at equilibrium, you cannot calculate Kc. So remember that equilibrium has to be present. Okay, that's one very basic rule for Kc. So now the first type of question is question type 1, and that is you're going to be asked to calculate the value of Kc. And there are basically two types of questions that you're going to get. One is you calculate the value of Kc given equilibrium concentrations. Now that doesn't really sound very difficult. Okay, if you're given equilibrium concentration, it's probably going to be easy to solve for Kc. But most of the time, the equilibrium concentrations are not just stated. I mean, you actually have to figure these values out. I mean, if the question is going to be very easy, if the equilibrium concentration is given, then what do you have to do? I mean, if you have this equilibrium over here and the concentration of NH3 and N2 and H2, they're all provided. You just put in the values and you're going to get the answer. Okay, but the question is usually actually it's I've never seen an easy question like that. The main problem would be that it's actually kind of difficult to actually find equilibrium concentration in the first place. So the question would be something like this. Like, so I'm going to write a question that initially, let's say 0.5 moles of H2 and 0.6 moles of Cl2 are mixed in a container. So this is your example question. So initially 0.5 moles of H2 and 0.6 moles of Cl2 are mixed in a container, and after several days, equilibrium is reached. And it was found out that so after several days, once equilibrium is reached, it was found that how much 0.3 moles of HCl was present. So after several days, it was found that 0.3 moles of HCl was present. So you're going to get a question like this. I said, what does the question state? The question is stating that like that initially he added, let's say these are H2 molecules. So initially he added these H2 molecules in the container, and he mixed them with Cl2 molecules. So let's say the green ones are Cl2 molecules, and it's given you the moles of both. So H2 and Cl2 were present initially, and then they started reacting. So there's a reaction happening. H2 and Cl2 are present initially. You've mixed them up, and then a reaction would happen, and HCl would be produced, and two molecules of HCl are going to be produced. Now, so slowly, one H2 would react with another Cl2, and they would produce two molecules of HCl. So two molecules of HCl are produced, and these are gone. They have reacted. Similarly, let's say two more molecules of H2 and Cl2, they react and they produce two molecules of HCl. So reaction starts happening and products start getting produced. But once products are produced, a backward reaction would also take place. I mean, forward was happening, then backward would also start. So, for example, the HCl molecules would again react and they would produce H2 and Cl2 back again. So both forward and backward reaction would start, and you'll get a mixture. At the end of the day, you're going to get a mixture which is going to contain HCl molecules and Cl2 and H2. Forward reaction would be happening, HCl would be produced, and at the same time, HCl would decompose to form H2 and Cl2 back again. Okay? Does this make sense? Is this clear? Baswar,
Yes.
Rida, Sanjida, is this clear? Achha, so the point is, the main point is that we need to figure out somehow. What we need to figure out is what's the equilibrium. I mean, what is the situation at equilibrium? Because once the rate of forward reaction and the rate of backward reaction becomes equal, then the quantity would not change. I mean, if X number of molecules of H2 and Cl2 are reacting to produce HCl, the same amount would be formed back again. Forward and backward would become equal. So to solve this question, what you do is you make a table. And the table is going to look like this. It's like usually it has, I mean, depending on the number of reactants, it's going to have three rows. The first one, and there are two more rows. Now, the first one is your initial, like the initial situation. What was the situation in the container right at the start? And the last one is the equilibrium situation. What's the situation of the moles right at the equilibrium once equilibrium has been reached? And since there are two reactants, so I'm going to draw a column for each one of the reactants and products. So initially, first thing, we're going to focus on the initial moles. Right at the beginning, what did the question state? The question stated that you had 0.5 moles of H2 and you had 0.6 moles of Cl2. So right at the beginning, you had 0.5 moles. Make it 5. And you had 0.6 moles of this. So that's right at the beginning. And how much HCl did he add? He did not add any HCl. So that means HCl, the moles of HCl are exactly 0 to begin with. But then he's saying that a reaction started, and after several days, an equilibrium was reached, and it was found that at equilibrium you had zero point 0.3 moles of HCl. So after several days, once equilibrium had been reached, you had 0.3 moles of HCl in the container. So that's the situation. I mean, that's all the information there is. So now observe carefully what's happening. Look at HCl. Initially, there was no HCl, but after several days, there's 0.3 moles of HCl. So that means that 0.3 moles of HCl got produced in the reaction. I mean, a reaction happened, and that reaction, I mean, there's no other way. It's the only way you could I mean, all of a sudden you had zero point 0.3 moles of HCl at equilibrium would be that a reaction must have happened and H2 and Cl2 must have reacted together to produce HCl. And exactly how much? Zero point 0.3 moles got produced. So 0 moles initially, and then all of a sudden after several days, there's zero point 0.3 moles of HCl. So zero point 0.3 moles got produced. Now this middle column is going to be the reaction. It's going to state the reaction that's happening. It's going to state what is getting reacted and what is getting produced. So I've already stated what's getting produced, which is 0.3 moles of HCl that's getting produced, right? And so far, is this clear? Minair, is this clear? Bazaga, Sanjita,
Yes.
Heba?
Yes.
Achha, now if zero point 0.3 moles are getting produced, that means some amount must have reacted. Some amount of H2 and some amount of Cl2 must have reacted. So use ratios. We know that zero point 0.3 moles got produced. So according to the ratio, if 0.3 are getting produced, then according to this ratio, 2 ratio 1, 0.15 of Cl2 and 0.15 moles of H2 must have reacted. I mean, that's the only way HCl could have been produced all of a sudden. Like at equilibrium, you have zero point 0.3 moles. So zero point 0.3 moles got produced when 0.15 of Cl2 and 0.15 of H2 reacted. So I'm going to add that. I'm going to add that 0.15 moles must have reacted. And over here as well, 0.15 moles that must have reacted. Okay, that's so, and hopefully this is clear. 0.3 moles got produced. So 0.15 moles must have reacted. Okay, the middle column is the one for noting down what's reacting, what's getting produced. So you started off with 0.6 moles, and you know that 0.15 moles reacted. So what's left? You're going to subtract the two. So at the end, you're going to be left with 0.45 moles, right? So initially you added 0.6 moles, but you know that 0.15 moles they reacted. So right at the end, you'll be left with 0.45 moles. And this one as well, you started off with zero point 0.5 moles. Initially, you added zero point 0.5 moles into the container, but 0.15 moles have reacted. The reaction has taken place. So you'll be left with what's out of 0.5, 0.15 are gone. So that's what 0.35 moles. Okay. Is this clear so far? Everyone, yes or no?
Yes. Yes.
Rida, Heba, is this clear? So Okay, that's pretty much it. Now you can actually figure out. Now you can figure out Casey. Now Casey, figuring out Casey would not be that big of an issue now, uh, because if you know the expression for Casey, you just have to you just have to add the equilibrium moles, but not moles. It has to be concentration. What's the expression for Casey? I'm going to write the expression for Casey in this case. The expression for Casey would be it's going to be so Kc would be in this case it's going to be HCl concentration squared, and the whole thing would be divided by I think H2 concentration and Cl2 concentration. Now also remember that the Kc expression does not deal with moles; it deals with concentration. How do you find concentration? Concentration can be found out by dividing moles by volume. We have the moles. We just need to divide by volume. In this case, let's assume that the container is 1 dm cube, just to make things easier. So I'm going to divide all my moles by 1 dm cube. That's the size of the container. So I'm going to get concentration. Okay, make sure you do this step at the end, that the Kc expression does not deal with moles, it deals with concentration. So I'm going to put these values now, the equilibrium values. It's going to be 0.3 squared, and you can divide this by H2, which is what is H2? 0.35 multiplied by 0.45, and it was being divided by 1. Can anyone tell me what the value is in this case?
0.571.
Take it 0.571. And what would be the unit for Kc? I mean, you found the value of Kc. What would be the unit for Kc?
Mole dm cube. Mole per dm cube.
Try and find the unit. It's going to be. Uh,
Yeah, different. Okay.
I mean, how would you find the unit? It's concentration. Concentration is taken as x, so it's going to be x squared divided by x into x, right? So what's left?
No unit.
Okay, there's not going to be any unit, so there would be. You don't write anything, or you write no units in this case. Now, one thing about this is, yes, Sanjeeta, it's TK. So one thing about this is that especially, and this only applies when there is no units. Like this last step, I told you that to find Kc, Kc deals in concentration, not in moles. So you should, as a habit, you should not put moles into the expression. You should put concentration in the expression. But under certain situations, you can actually just input moles, because let's assume that I did not know what the container volume was. So there's no possible way of finding the concentration if I don't know the volume is. So let's assume I had no idea what the volume was, and I'm going to take volume as V. Now, in that case, calculating concentration would be impossible because I have no idea what the volume is. But remember, when an expression has no units, this only applies when an expression has no units. If you look at the numerator terms and look at the denominator terms, they're equal. I mean, there are two terms in the numerator, there are two terms in the denominator. So if I input these concentration in terms of V as well, the V's are going to get cancelled out. It's going to be 0.3 divided by V squared, and at the bottom it's going to be 0.35 divided by V multiplied by 0.45 divided by V. So the V's, I mean, on the top it's going to be V squared, at the bottom it's going to be V squared as well. So the V's are going to get cancelled out. If the numerator terms and the denominator terms, they're equal, the number of terms are equal. So the terms they get cancelled out, and so this only applies in this particular case So there's this new point which I'm going to write, and that is that if Kc has no units, and this only applies if Kc has no units, uh, and how do you figure out no units? Numerator terms are equal to denominator terms, or same number of numerator and denominator terms. So you have the same number of numerator and denominator terms. So in this case, uh, instead of concentration, you can use moles. You can use moles directly. Okay, so you don't need to actually do this extra step at the end to figure out concentration. Otherwise, you would have to, because then if the numerator terms are more, like in this expression, like the NHT expression over here, if the numerator terms are like lesser and the denominator terms are more, divided by v is not going to get cancelled out. So you need to have v to figure out what the value is. Okay. Is this example clear to everyone?
Yes.
Yes.
So it's just a random question. I mean, आपका वो कल हुआ था P1?
नहीं 17th को MCQs थे.
हाँ MCQs ठीक है परसों वो कैसा हुआ था?
अच्छा था.
अच्छा नहीं इजी था कोई ट्रिकी क्वेश्चंस तो नहीं थे उसमें?
बस एक दो थे, ज़्यादा नहीं थे, but easy था overall.
ठीक है. So next अच्छा so next one. Let's try another one. अच्छा ये थोड़ा सा ना रेशियो this was slightly an easy question. क्योंकि इसमें ना H2 और Cl2 के जो है ना वो it was just simple 1:1. Let's try and do a question where the ratios are kind of more, I mean, not that simple ratios. So you have a question in which you have, let's say, 0.3 moles. So remember, equilibrium can shift forward, it can shift backward as well. So you have 0.3 moles of N2 and 0.6 moles of H2 and 0.5 moles of NH3 are mixed together. So moles of NH3 are mixed together. Now, when they're mixed together, after several days, when equilibrium has been reached, so initially they're not at equilibrium. But you've just added, you took a container, you just added a random amount of N2 and H2 and NH3. And there's going to be forward and backward reaction. So after several days, when the rate of equilibrium, when an equilibrium has been reached and the rate of forward and backward reaction are equal, the equilibrium has been reached and it was found that at equilibrium, so it was found that 0.4 moles of N2 were present. Let's make it 0.45. So this question that you have 0.45 moles of N2 that were present. First thing, make the table. It's going to be N2 reacting with H2. Okay, let's assume this equation is given, that this is the reaction that's happening. So you have N2 and H2 reacting to produce NH3. I'm going to make a table. And it's going to have 3 columns. Three rows, and for each so yeah, this is the table. The first thing is initial moles. Okay, let's copy what's happening initially, right at the beginning, initial. So you have 0.3 moles of N2. Is the equation balanced? It looks balanced. 0.3 moles of N2, and you have 0.6 moles of H2, और product के अंदर क्या है 0.5 moles of NH3, right? So this is what you added initially in the container, and the only information that's provided is that equilibrium pay. Once you have reached equilibrium, what's present is where does it state? It states over here that when they opened the container at equilibrium, it was found that 0.45 moles of 0.45 moles of N2 were present. Now, in this case, by just looking at the equilibrium mole of N2, you would notice that the reaction must have shifted backwards because the amount of N2 increased in the reaction. So whatever happened, the reaction was actually going in it was kind of shifting in the backward direction. There was more backward happening, and then equilibrium was reached. So the middle part is the reacted, and in the middle you need to figure out what is reacting and what is getting produced. The middle part is the important part. So initially you started off, the container had 0.3 moles. Now it has, after several days, it has 0.45 moles. That means 0.15 moles they got produced. They got produced. Okay, it's obvious. So 0.15 got produced. So I'm going to write 0.15 over here. It's going to get produced. Now to produce one, that means backward reaction must have happened and 0.15 extra must have been produced. So so it's 1:3. If 0.15 were produced over here, according to the ratio, 0.45 of H2 must have also been produced. Okay, so I'm going to repeat. I'm going to repeat what's happening. That initially you had 0.3 moles, and at equilibrium you have 0.45 moles. So that means 0.15 extra must have been produced. So to produce 0.15 extra, the reaction must have gone in the backward direction first. So to produce 0.15, it's 1:3. So if 1 is produced, 3 of H2 would also be produced. If 0.15 were produced, 0.45 of H2 would also be produced. So I'm going to write 0.45 moles of H2 were also produced. Then the next part is, if 0.15 are getting produced, some amount of NH3 must have reacted. So it's 1:2. To produce 1 molecule of N2, you need to react 2 molecules of NH3. So to produce 0.15 moles of N2, you would need to react double the amount. It's going to be 0.3 must have reacted. So over here, 0.3 moles are probably undergoing a reaction. They must have reacted. Only then is it possible that 0.15 on the other side would have been produced. Is this clear so far?
Yes.
Do you everyone else? Minal, is this clear? Sanjita, clear? Hiba, Rida?
Yes.
So now we can find the equilibrium moles. That initially I added 0.6 moles in my container. right? My initial moles. 0.45 moles extra have been produced. So I think at equilibrium, I'm going to have 1.05 moles, I think. That's the amount of moles that I'm going to have at equilibrium. I think that's what the sum is. And over here, initially I had zero point 0.5. Now 0.3 I have reacted. They're gone. So what do I have? I have 0.2 moles left. So I have 0.2 moles that are left in my container.
Sir, in the second one, why do we have 1.05 moles left?
नहीं, initially कितने add किए थे? We added 0.6 moles, right? But these were already present at the start. 0.45 moles extra have been produced. तो क्या होगा? Add होगा ना? Miran, is this clear?
Yes.
ठीक है. So, I mean, if they're getting produced, you need to add them to the initial moles. If they're getting reacted, you need to subtract them from the initial moles. So these are your moles finally at equilibrium. And the next part would be to figure out Kc. The expression for Kc first. Kc in this case would be NH3 concentration squared. And it's going to be divided by N2 concentration, and H2 concentration is going to be cubed. So this is going to be the expression NH3 squared divided by N2 concentration and H2 concentration cubed. Now in this case, you can't use moles. You have to use concentration in the formula. If you're going to put these in this formula, you always have to use concentration. So the container volume has to be given. And just to simplify things, the container volume is 1 dm cube. So the concentration would be 0.45 moles per dm cube, 1 dm cube. And you can then go and figure out what the answer is. Okay? Try and do this calculation. Tell me what the Kc value is. Achha, is this clear to everyone?
Yes.
Okay. Any questions about this? I mean, you have to practice this a lot. We're going to do past paper. All past paper questions are going to be very similar to this. And that's one type of question that you're given moles and you're given equilibrium moles. You have to figure equilibrium moles. Rida, that's, I said, the 24 dm cube thing. I mean, the container volume could be anything. I mean, we're talking about container volume. I mean, you could have any size of container. 24 dm cube is. Well, let me clear this. I mean, over here, these gases are present in a container. So, वो जो 24 dm cube वाला है, that's for 1 mole of gas. If 1 mole of gas, it has to be at RTP. So I told you I mean, this question it doesn't mention that it's at RTP, and it isn't even. I mean, none of the gases are 1 mole. Plus, they're present in a container. The container could have any volume. Rida, is this clear? चलिए ठीक है. Let's continue with this in the next class tomorrow. Okay, then take care. Allah Hafiz.
Allah Hafiz.